All right, good morning, ladies and gentlemen, students, and also our speaker, Dr. Mohd Khairudin Ramli. On behalf of the committee, I would like to warmly welcome you to the online collaborative short course 2025, a joint program between Telkom University and Universiti Teknologi Malaysia. Today, we are very excited to continue our journey with the chapter 5, IoT and cloud computing, under the grand theme Digital Transformation in Accounting, a global perspective on opportunities and challenges in Industry 4.0. Before we begin, as usual, I will share some basic rules for today's sessions. The first one, during the speaker's presentations, kindly keep your microphone muted. If you have questions during the talk, please write them into the chat box. We will address them later in discussion session. And also in the discussion sessions, participants are encouraged to ask questions directly to the speaker by unmuting your microphone. At the end of the class, please turn on your camera for a group photo session. And then the last one, don't forget to fill out the feedback form at the end of the program. It will help us improve our next sessions and also allow you to receive your EC certificate. I hope everyone will gain new insight and inspiration from today's discussion. Yeah. All right. In this session, we will explore how IoT and cloud work hand in hand, how connected devices rely on the cloud for data management, scalability, and intelligence, and how this synergy powers innovation in accounting. It's an honor to welcome our speaker from Universiti Teknologi Malaysia. We have Dr. Mohd Khairudin, will share this expertise and insight on this exciting topic. So,
yeah, I think we have some connectivity problems, so we just wait first.
yeah, I'm back. Sorry. Okay. Is it visible, Doctor?
Yeah. Now it's okay now.
I'm so
Coming back
sorry.
online.
Yeah, there is something like there is something with the signal in my houses.
I
So
see.
sorry for that.
Okay, sure, no problem.
Right. So we continue to Dr. Mohd Khairudin. I think the screen is yours.
Okay, thank you very much again. Thanks. Okay, I will share my screen now.
Yes.
Can everyone see my screen?
Yes, it's visible, Doctor.
Okay, all right. Wait a moment. Okay, Assalamualaikum and very good morning to everyone. So hopefully all of you in a mint condition. So my name is Dr. Mohd Khairudin Ramli from Azman Hashim International Business School. So today I'm going to be a guest lecturer for the University Telkom Indonesia. So the topic here today is basically a very interesting one, the Internet of Things, IoT and cloud computing. But we are going more deeper in terms of the smart connection powering the digital world. So again, in this kind of approach, we have just only 2 hours. It's a very short moment of time. So we have a lot of things to discuss, but of course, we cannot discuss everything in one shot. So I would encourage two-way communication in which you have anything you want to ask me during this session. You can interrupt me anytime, inshallah. All right. So I will go. From time to time, I will show some of the examples based on this one. And I also have an experience of giving consultation to the companies in Indonesia, Logicom Technologies, in terms of developing the AI ecosystem and so on. So I will share with you later on. All right. So every single minute, over 6 million devices talk to the cloud. So this is the number of currently the facts, the figures. Your phone, watch, car, even your refrigerators and so on. We have the LG refrigerators that have the ThinQ, for example. And today we will explore how this invisible conversation powers our connected world. So this is very important. What we will explore by today is basically we have 5 parts. Part number 1 is evolution of computing, the IoT and cloud connection. And we have part number 2, fundamentals of cloud computing. We have number 3, virtualization and modern cloud infrastructure. And we have part number 4, IoT cloud integration and real applications. And we have the challenging part of the, we want to explore the challenges part of the IoT and cloud computing. And what is the future trends of this one? And of course, by having the end of the activities post-lecture, we want to design the own cloud IoT system by group base of the activities. So the lecture objective of today is basically quite simple and straightforward. We want every single student to be able to explain the key concept and evolution of the computing from the traditional system. We have the old system traditional to the IoT cloud integration, the latest one, even the AI integration. And we want the students to be able to describe the fundamental models such as the IaaS, PaaS, SaaS, and so on. I believe everyone knows about this one. Understand how virtualization and illustrate how IoT and cloud work together to collect, process, and analyze real-world data. And then we want the students to be able to identify and discuss major challenges in the current global issues, and then envision for the future directions, such as the IoT, edge computing, and digital twins. So this one, basically what we want to discuss about today, and why this topic matters. Why should we care about this IoT or cloud computing? Number one, because of it is a core enablers of the industry 4.0. Very important. This is globalization issue, the connected world, and so on. So by 2028, over 80% of technology-based job will involve either IoT or cloud-based solutions. So this is basically on the research by Gartner, 2024. Every single student today is a part of the IoT cloud, such as the phones, apps, and smart campus technologies, e-learning, and so on. And the global shift towards sustainable digital ecosystem, SDGs, and so on, relies on smart cloud enabled systems. So this one is basically the data center or the data application that we want to have in our ecosystem. So as you can imagine, how many of these IoT systems you use daily, we can see from the smartwatch usage, the fitness tracker, and so on. We will be watch all the time, all day long, So e-wallet, ride-hailing apps such as Grab, Gojek, Shopee Food, and so on. We have a smart home such as a Google Nest, Alexa. We have the Apple ecosystem, online learning platform, smart parking or traffic system. Everything is basically under the IoT system, but some of them already integrated with the AI. Some of them just only implemented on the basis of the cloud ecosystem. So IoT is already part of our lives, from smart agriculture or to smart cities. Over 15 billion connected devices exist today. And this number is expected to reach by 29 billion by 2030. All right, so this is a very huge amount of numbers. So what is the Internet of Things? So this one is basically refers to a network of physical object things embedded with a sensor. So please remember this term of the IoT. IoT usually refers to the sensor, software, and connectivity that enables them to collect and exchange data over the internet. So for example, we have the smart irrigation system in the agriculture, by which it helps the farmers to irrigate or to put the watering into the soil to make sure the soil is they have the water or moisture. So they should have the moisture sensor. They must have the cloud to process. So the farmers, and at the end of the farmers, they have to have the mobile apps and auto irrigation control for the device. So fact and figures, in 2025, IoT generated data is expected to exceed more than 73 zettabytes. So you have to look into the numbers of zeros here. Zettabytes, very big numbers. 70% of new car produced in 2025 will have a built-in IoT connectivity. So as we can see, the new smart cars, the new EV cars and so on, they have their own IoT connectivity, such as the Tesla and others. So the IoT is basically physical world digitized. So this is the term of the IoT, right? So what is cloud computing? Cloud computing is very simple model for enabling on-demand access to shared pool of configurable computing resources, such as the servers, we have the storage, we have the application and services, but by the clouds that can be rapidly provisioned with minimal management efforts. So the terms here is basically minimal management efforts. Why we want to have the clouds? Because we want to have a minimal management efforts. So simplified, cloud equals to rent instead of owning servers or owning the facilities or infrastructure. So the example of this one is basically such as the Google Drive for storage, we have the Netflix for streaming, we have the AWS for computing, we have the Zoom that we use right now for the collaboration, and we have the lectures and so on. So that's currently uses cloud services today, a minimum of like a Google Drive, like a Google email, and so on. So this is the facts. All right. So why cloud matters for IoT? Why is it matters? Why is it related too much, very much with the IoT? IoT devices produce massive real-time data, but cannot store or you cannot process themselves. So they must have a third party or the friends to analyze or to process for the IoT. So cloud provides the infrastructure, analytics, and the scalability to handle this one. So the analogy is very simple. The IoT is basically the sensors, and the cloud is the brain for this one. So the data example is a single autonomous car generates 4 terabytes of data per day. Impossible to manage without cloud computing. So that's why the Tesla developed the supercomputer to help them analyze the roadmap, the ecosystem, the maintenance, the sensors and so on for the car. The key benefit of this one, cloud enables real-time insights, remote monitoring, and predictive analytics for IoT systems. So this is very important. So we want to see some of the evolution of computing models. We know that the majority of us is never went to the era of the 1960s, even for myself, starting from 1980s. So the mainframe for this one is starting from 80s, centralized processing, expensive, very expensive, big and bulky hardware. So the example of the IBM mainframes. So we have the 90s, distributed computing, network PCs sharing tasks. We have the network, Windows, and so on. Through the LAN servers, we have the physical servers over there at that time. And 2000, we have the grid computing, sharing global processing power, such as SETI at home, folding at home, and so on. So this is the duration of that one. And then we have the 2010, the cloud computing emerging on this one, starting from the Google Cloud, and we have the AWS. And 2020s, we have the age of fog computing, processing near device, such as the cameras, we have the smart cameras, we have the 5G IoT nodes, we have so many equipments or devices that have their own processing before they send to the clouds. So what we call as the age of fog computing. So they have the pre-processing before they send to the clouds for further processing. So cloud data centers now consume 2% of global electricity. It's a very big amount of energy they use, showing both power and sustainability concerns. All right, so this is the main issue currently. And the key factors or the motivation or the main factors behind the cloud and IoT growth, all right? As we can see here, the data explosion by 5 quintillion bytes generated daily. So this is the data explosion. So that's why we must have the cloud or IoT growth on this one. And 5G networks enables less than 10 millisecond latency and billions of device connection. Now we are moving on the 6G. Even some of the research showing that we are emerging into the 7G. So imagine that how this one is going to change the narration of the cloud and IoT growth. And AI integration, as we will use every day in daily usage, such as a ChatGPT and so on. 40% of IoT users case now involve AI analytics, all right? And then the cost efficiency, pay as you use cloud reduces upfront capital by up to 60%. Nowadays, small companies, they don't want to pay more upfront. They don't want to invest more on the capital investment, big investment on the infrastructure, such as the IT and so on. So they want to invest on the cloud computing, on the service base, such as the IaaS or PaaS or SaaS, because of they don't want to develop the software by themselves, or they don't want to hire the consultant to develop the IT-based ecosystem. They just use whatever they use and they pay for whatever they use, just only that. So they don't have to do the maintenance on the infrastructure and everything, all right? So sustainability drive, cloud provides shifting to carbon neutral data centers. So this one is going to help in terms of the SDG score, all right? So the IoT plus cloud is basically the smart ecosystem. So the relationship is IoT collects data from the physical environment by sensing devices. The cloud stores, process, and analyze the data. Actionable insights are delivered to the application directly to the end user. So this is the basic concept. The use case example we have healthcare. The patient's vital signs to cloud AI, and the system triggers the emergency alert. So this one is basically processed by the cloud AI, and they have the device at the end of the customer or at the end of the hospitals to have the emergency alerts. And then we have the smart agriculture, we have the soil data analysis, and then we have the irrigation decision based on the weather conditions, based on the current ecosystem of the agriculture, environment, and so on, based on the predators, even so. And smart cities, they have the traffic sensors, plus cloud analytics, congestion prediction. And as we know, we use the Waze, we use the GPS, Google GPS, and so on, to help us to navigate and so on. That's part of the IoT and cloud as well. So statistically, smart city cloud market value projected to reach USD 3 to 5 billion by 2030. It's going to be a big and highly potential. If anyone wants to venture into the business, this is going to be a big amount of market value, highly potential. So this is the real world example. We have the smart city cloud, such as the Jakarta smart city, which is very good one, very good example. 1,500 plus environmental sensors feeding into the cloud platforms all the time, 24/7. Real-time data shared with city apps for traffic, weather, and flood monitoring, which is increased in terms of the efficiency and effectiveness of the daily usage of the people. If we want to know the current condition, we want to plan and so on, it's going to be better and better compared to the conventional one without the sensors and so on. Uses hybrid cloud architecture with AI dashboards. So this is something that is very, very new, emerging, and very good for the ecosystem of the residents. Lessons, IoT and cloud integration transform city governance into the data-driven decision-making, which is reduce the time for us to make decision and make it more efficient for us to counter anything, including the weather conditions and so on. All right. So the key insights of first part of the lecture is basically very simple. IoT connect things, cloud connects intelligence. So together they form the foundation of Industry 4.0. It's going to be the Industry 5.0 soon. Evolution of computing has led to the convergence of physical plus digital worlds. So this is the reality now. So we want to understand how cloud computing actually works and what is one of IoT cloud system that you use daily without realizing it. Guys, anyone of you? Which is one IoT cloud system that you use daily? Anyone can give some feedbacks on this one before we move to the next part? Thank you. Example of IoT, cloud-based system. Anyone, please?
Yes, everyone, you can type in the chat box. If you're shy to turn on the camera, you can type your answer in the chat box.
Yes, thank you. Thank you, Dr. Anissa. Okay, all right. If you have anything you want to interrupt me, you want to ask anything, you can ask, during the lecture session. Okay, no problem. If no, I'm going to continue with the second part of the lecture. We have a very short amount of time. 2 hours is very short.
One answer, maybe Google Drive, they say.
Yeah, definitely. Google Drive is going to be very simple. Although we have the Google Drive, the end part of the IoT is basically our handphone or our device, such as a smart home and so on. So this is a good answer. Thank you very much for the answer. All right. So we go to the fundamentals of cloud computing on the next part of the lecture, which is part number 2, right? So the shift to the cloud. So when was the last time that you still remember that you stored something on the USB drive? It's going to be very rare things to be happen nowadays because of you are using the cloud more than your USB drive itself. But for some cases in the areas that we don't have the good connectivity to the internet and so on, of course, the USB drive is going to be more important than the cloud itself. But in the cities area, in the emerging countries, in the modern countries, the world have shifted from the local storage to the cloud first operation, such as when we use the iPhone, we have the iCloud rather than we store into the physical data and so on. So this is the current evolving things in our life. So the key facts, 94% of enterprises globally uses cloud services rather than the physical services. And global cloud market, if you can see the figure, USD 675 billion in 2024, projected to reach by 1.4 trillion in 2029, meaning it's going to be a big business, a good amount of business over there. Because I'm from the Faculty of Business, I'm looking more on this kind of things, although my background is on the IT. So 60% of global corporate data now stored in the cloud. As you can see, the data is emerging and it's going to be enlarged to be more and more. So we can see the trends and we get better from time to time based on the previous trends we study, and we can predict the future of the things happening in the business. So defining cloud computing in the NIST definition, all right? A model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, networks, server, storage, application, and services that can be rapidly provisioned and released with minimal management efforts. Again, the keywords here is basically minimal management efforts, by which we want to increase the efficiency and effectiveness of the ecosystem by having that we don't have to look into the management efforts anymore. It's going to be a third party who controlling the management for us. We just give them the direction, they will follow, they will do the integration, they will do the data management and so on, without us have to do the coding and so on. All right. So the simplified things of this one terms, the cloud computing means renting IT power instead of owning it. So the analogy, if you own the things, you buy a car, you have to do the maintenance by yourself, it's going to be very expensive. Of course, you have the flexibility, but the real thing is we have the cloud, such as a Grab car. We just only pay for whatever we use, and we have the scalability in time, no problem, and no maintenance at all. Similar to the server condition. We have the physical server, we have the cloud server, we have the traffic control. Whenever we have the physical server, we have to control the traffic's amount of the traffic. We have the capping. But when we have the cloud integration of the server, we can customize the clouds. We can add more traffic according to the events. Based on the events, we can pay more to make sure they can support more traffic on certain events. We can pay less during the normal time, normal period. So this is the thing that we have to understand on the cloud computing, the flexibility of that one, all right? So 5 key characteristics of this one. Number one, on-demand self-service. Users can create resources anytime, such as the create AWS virtual machine in seconds, and broad network access accessible from any device, anywhere, such as a Google Docs on phone, laptop. Even we can change to the other places and so on seamlessly without any problem. Resource pooling, shared infrastructure for multiple clients, such as the Gmail or Netflix we share with our family ecosystem. Rapid elasticity, scale up, down instantly based on our ROI, return on investment, based on our prediction, based on our target of sales and so on in terms of the business, such as the e-commerce during 11/11 sales. You know, that times, basically, we have a lot more traffic compared to other times. So we have the flexibility to change the traffic by scaling up things easily. And measured service, pay for what you use. We have the cloud storage subscription. Anytime we can increase, anytime we can decrease based on the demand as well. So as we look into the traditional versus cloud computing, we have the hardware. Traditional computing, we have own on-premise, meaning we have the infrastructure on the premise. While for the cloud computing, we have the hosted by the provider. But again, we have to look into the security concerns as well, because of some of the servers resides in our country, some of the servers resides internationally, maybe other countries. So when you have the sensitive information, you can store locally. When you have more general information, you can store internationally. So this one is basically the decision by your organization. So we have the cost by the traditional computing. We know that we have the high capex, meaning the capital operation, capital cost of the expenses of this one. So we don't want to have high capex because of we want to save money. We want to be more on the OPEX because of we want to reduce the burden of the ecosystem and so on. So low OPEX by the cloud computing, pay as you go. So this one is basically more beneficial for the new startups, new company. And scalability, we have the fixed capacity on the traditional computing. Although we have the flexibility to add up more and more infrastructure from time to time, where it requires the human capital, human power, knowledge, workers, and so on, is going to be a delay in terms of construction, implementation, and so on. While having the cloud computing, we have the capabilities of instantly scale the things based on our needs. So this is the comparative things that we have to have in our mind. Such as for the maintenance, we must have the in-house IT team. Otherwise, we have to appoint other consultants to help us doing the maintenance. It's going to be very costly. While for the cloud computing, we have the provider managed. We don't have to think about this one. It is 24/7, but depending on the provider itself. So you must look into the provider's capabilities and brand and their reputation and so on. Such as for the accessibility to the traditional computing, minus in terms of the local accessibility, while for the cloud computing, +1 is going to be a global via internet. So it's going to be very simple, very easy to manage. It's everywhere. You can be everywhere. The server can be everywhere without any problem. So moving to cloud reduces infrastructure costs by more than 35%, increases agility by 40%. So this is the research by Accenture 2023. So this is the impact. So cloud service models, we have the big three that you have to understand. You have to put your bear into your mind. The infrastructure as a service, number one, IaaS, by which we have the virtual machines, we have the storage, we have the networks, such as the user controls, OS, and apps. Example on this one, such as the AWS EC2, you can Google this one. Google Compute Engine, Microsoft Azure, VM. So this one is basically the infrastructure as a service. You use just only, you pay for whatever you use in terms of the infrastructure. The second one is the platform as a service, PaaS, platform to develop and deploy apps without managing hardware. For example, we have the Google Apps Engine, we have the Heroku, we have the AWS Elastic Beanstalk, and at the time, please, list down more on the PaaS in the chat box. It is better for us to have the discussion later on. And then we have the software as a services. This is a very popular one, fully hosted by software via web or browser. And for example, Gmail, Zoom, Canva, and Salesforce. So I have also several partners in the industry in Malaysia that currently transforming from selling their software, and then they put their software in terms of the services, software as a services. This is more flexible for the users, easier to capture the audience and getting the business more robust. All right. So SaaS currently represent 46% of all cloud spending. So this is to show that the importance of the SaaS in order to help the end user consumer to transform their small business into the cloud-based services by using the SaaS. All right. So the cloud deployment models, we have several models of this one, such as number one is the public cloud, shared by public, owned by providers. Use case on this one, such as the startups or new SMEs. So the example of this one, AWS and Google. And private cloud, owned by one organization, such as the more sensitive industries or the sectors such as banks, defense, such as the VMware, OpenStack. And we have the hybrid cloud, by which the combination of both public and private. This one is basically more on the organization or enterprises. And the community cloud shared by similar organizations, such as the university, NGOs. We have the cloud, government clouds as the US and other things in the localities. All right. So 70% of organizations now use hybrid or multi-cloud strategy. So this one is by FlatZera 2024. All right. So this is the cloud deployment models. So how cloud works? All right. Simplified version of this one. User sends requests such as run apps, store data, and so on. Request goes to the data center via the internet. Virtualization layer allocates resources dynamically according to the request. Meaning if you put a request to 10, virtualization layer puts the 10 resources to help you. Cloud software manage and monitor the users to make sure that they can increase or they can improve the services later on. And then when uploading a photo to the Instagram, for example, your food access to the internet, goes to the data center, AWS S3, goes to the global CDN, all right, back to the viewers in second. So this is a basically cloud data networks. So this is the how the cloud works in the simplified version of explanation. Of course, it's going to be more than that. We have a lot of codings and so on happening, but this is the basic concept, all right? So virtualization, the cloud enable. So we have the virtualization by which the creation of a virtual rather than physical version of hardware, OS, or storage, enabling multiple virtual machine to run on one server. Meaning you have one server, you have a different version. OS, you have different version of things that run different things in one time. So the key components, we have the hypervisor. So this one, we go into the a bit into the technical part, but of course, it's still on the introduction part. So you can use Google, you can use AI to analyze this one to look further. Of course, we don't have time, 2 hours to explain everything. I need you all to do your own research. So the key components of this one, we have the hypervisor, VMware, Zen, KVM, manage VMs to manage VMs, virtual machine, independent isolated environments, containers, the new one, Docker, Kubernetes, lightweight, faster the deployment. So this one is basically the emerging things happening in the cloud, such as for the cloud enablers. So the real example, AWS uses Zen-based hypervisors to host millions of virtual servers globally to provide for their clients. So virtualization improves server utilization from 15 traditionally to 80%, cloud VMware 2023. So this one to show that how virtualization helps to increase or improve the utilization of the cloud globally. Why? Because of the utilization of the hardware or the infrastructure is going to be pushed to the max of their capacity by having a parallel VM, all right? So advantages of cloud computing. Number one, scalability. Again, as we discussed previously, auto scale up, down based on demand instantly. Cost reduction, pay only for what you use. You don't have to pay for the infrastructure development. You don't have to pay for the maintenance and so on. And accessibility is going to be anywhere and time whenever you have the internet connection over there. Disaster recovery built in redundancy and then collaboration, real-time network or teamwork. Sustainability, shared infrastructure lowers energy waste by which we can put the SDGs into the context of the target or ESG, all right? The global impact of this one, cloud adoption reduces carbon emission by more than 60% compared to none to on the prem servers, meaning on the real or the physical servers. And then business reports 20 to 35% faster innovation cycles due to the cloud flexibility. So this is the impact of the cloud computing towards the, the ecosystem of the business, towards the ecosystem of the SDG, empowering of the people and so on. It's very important. But we have some challenges here in the cloud computing, such as the security risk, such as the data breach, unauthorized access and so on. We have the data privacy to be compliant with GDPR, PDPA, and so on whenever you share your information. Downtime, network failures, provide outages. We have the force majeure, which is not stated here, such as the earthquake, the disasters and so on. So the vendor lock-in, hard to switch providers because of this tailor-made based on one provider. So we have to have the backup plan as if we are the clients of using the cloud computing. And skill gaps, need cloud certified workforce in order for us to handle this one. So this is the challenges. As for the statistics, 42% of organizations cite security and compliance as their top cloud challenge. So this one we have to understand, we have to know as well, we have to aware. An example, 2019 Capital One data breach, 100 million records exposed via misconfigured AWS S3 bucket. So this one is basically the things that we have to consider, we have to look into further because of the security matter concerns every time we share our information or data. All right. Okay. So cloud computing in action, everyday example. So we have Netflix streams to 238 million users via AWS cloud globally. So this one is basically a vast amount of people using a parallel servers cloud at one time. And we have the Shopee, Tokopedia, scale automatically for sales spike 11 during 11 for example, 9/9, for example. So this one is basically scale automatically. And we have Zoom. Currently, we have the host more than 300 million things daily using cloud servers. Is going to impact our daily, what we call routines and so on. If you don't have this kind of things such as Zoom, WebEx, and so on, imagine it, we have to go physically. It impacts our own maintenance. We have our own, cost and so on. So this one is basically helps us to reduce the things, reduce the cost, and improve our living. And Spotify stores petabytes of user data for AI-driven playlists and so on to decide what's the best for the users, what is the best for the people, and so on. So we have also in the UTM and the university, other universities using the LMS platforms running on cloud infrastructure as well, cloud computing in action, everyday examples. So the key insights, every digital service today is basically cloud powered, even if users don't realize it. So we have to embrace this one. We have to face with this one because of it's going to be unstoppable. So we have to be adaptable to this one, and we have to swim and jump into this one. All right. So to recap, so far what we have learned, so now you should be able to define what is cloud computing and then differentiate between traditional and cloud computing. So we know now the service models such as the IaaS, PaaS, and SaaS, by which the IaaS is basically infrastructure as a services, P is platform as a services, and S as a software as a services. And explain deployment models and visualization. And we want to, we also have the ability to recognize the benefit, challenges, and real world users. And we understand the backbone cloud computing. So what next is basically we want to explore how it connects with IoT to create intelligent system. All right, if you have anything you want to comment, if you have anything you want to ask, you can ask me now, or else you can put the question in the chat box. All right, so we will continue on the next part. All right, okay. Any questions, please, if you want to ask directly, or you can put into the chat box.
Any questions, students? So far?
Yeah, any questions?
Okay, let's see. I have a question, sir. What is the difference between database and data center?
Okay, actually it's going to be what we call some complexity in doing the answer on this one based on the context of your ecosystem. Data center and database is basically more or less the same. All right, data center and database is going to be more or less the same, depending on the on your perspective. Meaning, if you put a data center, for example, one big data center to process things is going to be what we call different compared to the database. Database is going to be the storage to store the information without processing. All right. But for some database, they have the pre-processing, as we see the edge or the fog computing. So fog processing. So this one is basically integrated to the database. And for the data center, usually for the data center, we have the processing power inside the data center. So we have the what we call algorithm to segregate what kind of data, what kind of things to put there automatically rather than the database. Database is more like we are managing our own database without having the processing power inside it. But for some conditions, it's going to be interchangeable, meaning some of the database, they can transform into the data center. Some of the data center, they can transform into the database, depending on the context of your condition. Hopefully, I answer your question.
You're welcome, Andy. Okay.
All right. Any other questions?
Continue. Okay, any other questions, students?
All right, so I think I will continue on the visualization and modern cloud infrastructure. Okay. So why visualization matters rather than the physical infrastructure? Why visualization matters? All right. So do you know that one physical server in the cloud data center can run hundreds of virtual computers at once? So this is the emerging things happening right now, the new innovation by which we have one server, but they can run virtual computers at once, more than hundreds of virtual computers at once. So based on the previously the traditional methods, such as we have one computer can run only one OS and so on. For some cases, we have one server, we have the Windows OS can be to be separated into the server screen and so on. But now we have the hundreds of virtual computers at one by having the one physical server in the cloud data center. So this one is basically the visualization allows multiple independent systems to run at one physical machine, by which we have the independent system again. Independent systems, meaning you can have the different tasks, different specialty, and so on, according to the systems that you put inside the one physical machine. Maximizing hardware utilization and enabling scalability, the very foundation of cloud computing. What we are talking about currently is basically the normal processing power, by which is going to be something what we call a new innovation by quantum computing. If we put the quantum computing in the future, in this kind of things, it can run more than millions of virtual computers at once, because of the power is going to be exponential compared to the conventional processors. All right, so this is the cloud computing, the foundation, the power of this one. So before visualization, average server utilization was only 15 to 20%. With visualization, it's going to be up to the level of 90% efficiency, rather than we waste the energy, we waste the infrastructure just only by 15 to 20% on the traditional method. So this is the emerging things happening now. So visualization, virtual version of computing resources such as server, operating system, network, or storage by using the software. All right, so this is the visualization. So simplified analogy, think of one pizza with a multiple slices. So they have their own, so the people will get their own portion, but shares the same base. So the type of visualization, we have the server visualization, multiple servers on one physical machine, or we have the network visualization, which will LANs, SDNs, storage visualization, pulling of physical disks, and with desktop visualization, virtual desktops. So previously, in the traditional era, conventional era, we have the desktop visualization, such as to save the cost of the infrastructure. One company, for example, in the training department, so they want to have one computer, but they want to have more than single desktops. But the thing is, the utilization of the software at the time is not up to current level, by which whenever you share the desktop to the 2 or 3, split the desktop into 2 or 3 for one computer, it's going to be lagging because of the utilization of the software is not up to the current situation. Now we have the cloud interfacing and we have the different things. So nowadays we have the more power in terms of the visualization due to the IoT and to the cloud computing. All right. So the hypervisor, the cloud's heart, a hypervisor or virtual machine monitor is a software that creates and run multiple virtual machine on a single physical system. So this one, type 1 bare metal, runs directly on hardware most efficient, such as a VMware, ESXi, Microsoft Hyper-V, KVM, and so on. Type 2 hosted runs on top of OS for desktop or testing, such as a VirtualBox, VMware Workstation, and so on. So type 1 hypervisor power nearly all enterprise and cloud data centers, supporting millions of VMs daily. So please look into this one, type 1 and type 2 into the AI and Google it. And please do some comments on this one based on what it uses and what currently the needs for this one to run. All right. So the virtual machines, what is the virtual machine? Each virtual machine is a self-contained operating system with its own CPU, memory, storage, isolated yet sharing underlying hardware. So this one is basically everywhere in the server or data center. Example, a cloud provider like AWS may host 1 million plus VMs across its global regions. So this one is basically an example of the one AWS hosts more than 1 million virtual machine based on the what they have the server. All right. As for the real use, developers deploy test environments or web servers on VMs without worrying about hardware. So this one is the advantage and benefit. Rapid provisioning, number one. Isolation and security and flexibility for multi-OS environments. Not just only Windows, we have the Ubuntu, we have Linux, and so on, integrated together in one hardware configuration. So this is the virtual machines that we have currently in the current changing environment of the technology. All right, so we look into the containers. The next step in the virtualization. Containers basically are lightweight, standalone units that package an application with all its dependencies running on a shared operating system kernel, such as this one. We have the comparison of the container versus virtual machine. If you look into the right one, we have the containers are isolated but share OS and where appropriate. The containers here, as you can see, we have the bins, libraries, and so on, bins, libraries, different app, as you can see, app A, app B, and so on. So differently structured compared to the hypervisor. So this one is basically the VM. As you can see, the VM, they have their own guest OS separately, but the structure of the container is quite different compared to the VM. So this is the next one. All right. So the comparison, the feature of the virtual machine and container for the OS. Virtual machine, each one has full OS. So container, they share the host OS. All right. So that's why the startup time for this virtual machine is going to take longer, for minutes, while for the container, seconds, because of they share the same OS. And the size of this one, because of the virtual machine, is going to be big, because of each one has full OS, they have to be GBs. But for the containers, they just only have MBs. So example tools such as VMware, KVM. While for the container, they have Dockers, Kubernetes, and so on. You can do the research on this one. So Netflix uses Kubernetes-based containers to manage 100,000 microservices daily. So containers can improve resource efficiency up to 30% compared to the traditional VMs. So the container is basically the new emerging things happening in the virtual world. All right. So virtualization in cloud providers, we have the cloud examples of AWS EC2 runs on Xen-based or Nitro hypervisors. Microsoft Azure uses Hyper-V for VM management, and Google Cloud built on KVM kernel-based virtual machine. So we have the AWS Nitro system. You can look further this one into AI or Google. We are not talking about the technical things here. Specialized hardware for performance isolation and support over 33 instance families and 500 plus instance types worldwide, and enables security isolation for multi-tenant architecture, meaning it's going to be more fast in terms of the security matters. So that's why it is very important for us to understand what kind of virtualization happening now in the cloud providers to make sure that we can fit the ecosystem to our needs. All right. The insights, modern virtualization blends hardware and software optimization, ensuring the performance and security at hyperscale. So this one is very important. All right. So the role of virtualization in cloud computing. So virtualization enables, number one, the resource pooling. Multiple clients share the same hardware efficiently. That's number one. Number two, elasticity. Quickly scale resources up or down. As previously discussed, we know that the traffic of the people is going to be different from day to day, from the events and to some peak time and so on. And then the cost reduction, one server does the work for many. So this one is basically the most important elements of the virtualization, by which the cost reduction is helps the company, small companies, even medium companies to navigate further in their business ROI. And fault isolation, VM's failure doesn't affect others, meaning they stand alone. And disaster recovery, quick migration and backup replication. Now we have the mirror, we have the twin system and so on to make sure that everything is backup into one another if anything happens. Visualization allows 80% faster system recovery during outage. So this one is basically being implemented by IBM Cloud 2023 and being proven by them. So without any kind of worry. Okay. So we move into the VM migration. By this, keeping the cloud always on, how they can keep up everything 24/7. So VM migration is the process of moving running virtual machine from one physical host to another with a minimal downtime. So it's going to be very similar, such as the Google Cloud and so on. So the techniques is basically live migration, move active VMs without shutdown. They have the live migration. So cold migration, VM stop before transfer. This one is basically happening due to some things such as the security factors, sensitive issues and so on. Storage migration, move only storage disk. Cross-platform migration between different hypervisors such as the VMware to the KVM. So for example, Google Cloud performs thousands of live migration daily to update hardware seamlessly. So this one is basically some example from the Google. Okay. So if we look into the virtualization to cloud native infrastructure, the concept evolution starting from the 2000, we have the virtual machines such as the VMware, such as Zen. 2010, we have the containers, we have the Dockers, Kubernetes, and 2020s, we have the serverless computing such as the AWS Lambda, Azure Function, and so on. So serverless means no server management. Developers deploy function, not infrastructure, pay per execution, e.g. such as a millisecond operation. And then as for the example, AWS Lambda handles 10 trillion requests per month. So this is the trends nowadays. Yeah. So virtualization to cloud native infrastructure. But of course, we have several challenges in the virtualization, such as the security risk, VM escape attacks, container vulnerabilities. So this one is basically the security risk. And we have the performance overhead, virtual layers at processing cost. So this one is a normal things that we have to look into the overhead of the performance in terms of the operation and management complexity, orchestrating thousands of VMs. This is the complexity of the management. Compatibility, different hypervisors or different platforms, how to affect the compatibility, and cost of licensing proprietary hypervisors such as the VMware and others are expensive. So the trend is the cloud platform now invest in zero trust virtualization and hardware assisted security such as the Intel VTX, AMD SEV. So this one is basically for you to look into the challenges into the virtualization to make sure that we understand the current things and then the emerging things before we jump into the conclusion. All right. So this is the challenges. Okay. So some of the example, we have the Netflix cloud architecture. As for the case study, Netflix migrates to AWS virtualized cloud to handle streaming to 230 million users. So the architecture highlights users microservices in containers, as we discussed previously. Why they use containers? Because of the uptime, the startup time and so on is very fast compared to the VM. And then auto scaling with EC2 and elastic load balancers and redundancy across multiple availability zones, real-time analytics powered by AWS Lambda. So this one is basically a serverless. So results of this one, based on the integration, 99.99% uptime with seamless performance during global spikes. So this one is the Netflix. Currently, they use the cloud architecture of the AWS virtualized cloud. All right, so this is the benefits of having the new technology. All right, so some recap on this one. So virtualization, the foundation of cloud scalability, hypervisor manage multiple VMs efficiently, and containers lightweight modern virtualization. VM migration keeps cloud services uninterrupted and evolution continues towards serverless computing for ultimate agility. So now we understand how infrastructure operates under the hood. So now we want to integrate to the IoT. Before we move forward, do you have any question, please? Anyone? Do you have any question? Any question, guys?
Question, everyone? Please, before we continue, can you give me a reaction, a thumbs up or hi, to make sure you're still here, not sleep? Can
I hope
you?
everyone is still here.
Can you give a reaction, everyone? Okay, Andre. Only Andre. Come on. Give a reaction, please. Okay, Aksa. Okay, they still here, doctor.
Okay.
Okay,
Thank
all
God.
right.
Alhamdulillah, everyone's still here, It's going to be a good thing.
Yeah,
All
they
right.
still they waiting for you maybe to finish, or maybe they will ask a question later, maybe.
Okay, it's going to be, I think it's going to be finished earlier than 11 because
Okay,
of I I thought that there will be a lot of questions, discussion, and so on, but still fine because obviously we have the activities at the end of the session, but it's going to finish earlier, inshallah. All right.
all
So we
right.
move to the next part of this one, IoT and its integration with cloud. Okay. Okay. So the question is, if your smartwatch tracks your heart rate in Bali, where is that data really stored? So this one is the ethics question, sometimes in terms of the privacy and the security settings, when we go into the discussion of the IoT, when we go into the discussion of the cloud, it's going to be something that is very sensitive. Where is the data really stored? So some of the sensitive manners is supposed to be us to decide, either we want to store the data into the local data or into the international data. But for the personal, it's going to be quite flexible. But for the government, for the military, and so on, they have to be more, concerned about this one because of the location of the data plays a very important role. So we have to understand that whenever we have the cloud, we have to understand where is the server of that cloud is placed. So for us, for the what we call the individuals, it doesn't matter very much since as long as we are not sharing our sensitive content. But for the government, again, in case of one of us involved in this kind of ecosystem, we have to understand usually for the localities, for the government, they must have the server in their local condition, in their local ecosystem. But for the what we call the personal things, or for the individuals, we can put the cloud everywhere in this globe. So no problem at all. So we have to understand that one. So the key concept, IoT devices are powerful at collecting data, but the problem is they're weak in terms of the processing and storing it. So they must have the cloud integration. So that's where the cloud comes in. It handles large scale storage, computation, and analysis. So by 2030, there will be 29 billion IoT devices globally. So this is the estimated, with 70% connected via cloud platforms. So I believe there will be more than that, more than 17%. All right. So the IoT cloud relationship is basically the sensors and the brain. Such as for IoT, we have the sensors to collect the data, to look into the data, what kind of the parameters you want to secure, either the temperature, heart rate, breathing signs, and so on and so forth. So this one is basically the sensors to collect the data. But for the processing, is going to be the cloud to take care of, such as for the brain, analyze, decides, and so on. All right. So the process flow is very simple. We have the data collection from the sensors, and we have the transmission, gateways, internets, and so on. We have the cloud ingestion to store and to do the analytics. And we have the final one, the feedbacks to the action, user interface, or automated responses. So this one is basically the process flow for the IoT or cloud relationship. Example, smart home aircon, air conditioner, adjust temperature, using data analyzed in the cloud or based on the request. So this one is basically IoT cloud is a relationship by which the sensors and the brain. And the IoT cloud architecture in the 4-layer model. So we have to understand this as well, by which we have the layer number 1, the perception layer, by which we have the sensors, actuators, we have the RFID and so on to measure the temperature, to have the camera, to have the GPS and others. And we have the second layer, the network layer, to transfer the data from the sensor to the server or to the cloud via Wi-Fi. We have a 4G, 5G mobile data, LoRaWAN, and so on. And we have the middleware, the cloud, which is the storage of the data and processing. We have the AWS IoT Core, Google Cloud IoT, and others, and also our own or the customized our own ecosystem. And we have the application layer, such as a user apps or dashboard to give the feedbacks, such as the smart city apps, feedback, Fitbit analytics, and the Apple ecosystem. So this one is basically the 4-layer model that we must have in the IoT cloud architecture. So this architecture transforms raw sensor data into valuable real-time insights. So this one is very important for us to understand. So data flow in IoT cloud system, we have the step-by-step. Number one, data ingestion. IoT devices sense reading, all right? Such as humidity and the data pipelining. Cloud platforms organize incoming streams into storage pipelines, and they transform the data raw signal into the meaningful metrics. This everything is inside the clouds, such as the voltage, change to the temperature, and so on. And we have the storage and retrieval. Data stored in scalable databases. Now we have non-SQL object storage and so on. Analytical insights, real-time dashboard, AI-based prediction. So, for example, ThinkSpeak converts sensor voltage into temperature and visualize it via MATLAB analytics. So this one is basically a combination of many things, such as the IoT, we have the cloud storage, we have the cloud computing, we have the AI as well. All right. So this one is the data flow in IoT cloud systems. So the cloud as the IoT enabler, benefit of using cloud for IoT. Number one, again, scalability, because of we know that they can handle billions of device connection without any problem. And second is that where compared to the conventional method by which we have our own server, physical server, and time to market faster because of we can deploy the IoT faster, and security and encrypted communication access control based on and cost efficiency pay-per-use infrastructure. Currently, nowadays, we know that even for the AI, even for the cloud, even for the server and so on, we can use the pay-per-use infrastructure. For the AI, for example, business, we have the ChatGPT Plus, we have the ChatGPT Pro and so on. We can use based on pay-per-use token, meaning if you use, we have one question, they will charge based on one question. There's no kind of the monthly subscription anymore. They're based on the pay-per-use infrastructure. So this one is something new, emerging trends. But the cost is very $0.00001 only. So this is the token. So you can have a lot of questions. You can have your own large language model to make sure that you can provide the service to the customer, for example, as a front desk, chatbot, and so on and so forth. All right. So example, Google Cloud IoT Core integrates 1 million plus devices for smart city projects. Okay. As for the statistics, IoT cloud integration can reduce maintenance costs by more than 35% and improve analytics speeds by 45%. So this one, the facts and figure, all right? So IoT cloud platforms, we have the global overview here. The platform for this one, AWS IoT Core, the key features, device registry, MQTT protocol, and so on in the smart industry. So we have also this Microsoft Azure IoT Hub, and then Google Cloud IoT and ThinkSpeak, MathWorks, and Nimbit, Google App Engine, and so on. So before I move forward to this talk, I would like to show some of the previous things that I have done with the industry organization in Indonesia. Can you see the picture over here? So this one is during my visit at Medan with the Logicom Technologies, all right? We were appointed as the consultant for their IoT development and business ecosystem. As you can see from this hotel from the Logicom Technologies, they integrated 100% IoT and the cloud computing in this one to make sure that they can monitor the use of the electricity and the use of the facilities inside this hotel, by which they can decrease the cost of running the electricity and so on, and based on the demand by the customer. So you know that a lot of wastages from the utilities in the hotel ecosystem or the hospitality ecosystem, by which the consumer or the customer forget to turn off the aircon, forget to turn off the lights and so on. whenever they leave the room and so on. So this one is basically they can monitor, but of course with the privacy and so with the security factors takes into the consideration. So this is the more successful projects in the Medan, all right, monitored by us. So this is the device for the IoT, all right, the integration between the sensors IoT and how the data transform and being sent to the cloud before processing and return back to the ecosystem. So this is one of the example, the project in the Medan as well, involving with the residents, integrating their homes into the smart homes, all right, by having the locally developed IoT device, and later they put into the integration of the iCloud, into the cloud integration. Again, as by our own our consultation helps them to maneuver and to manage their business development and so on with their clients. All right. So this is in the housing residential of the people, the use of the IoT in the ecosystem. All right. So this is one of the example of the device IoT that being used to control the ecosystem. All right. Just some insights to show you the real application of the IoT and cloud computing. All right. Okay. Any question, guys, before we move forward? Any question? If you have any question, you can interrupt me anytime. Okay. So the next one, communication protocols for IoT cloud. The common protocol, message queuing, telemetry, transport, lightweight, ideal for low bandwidth, and so on. So we have the HTTP, HTTPS, we have the co-app, we have the MQP, and RESTful API architecture. So this one is going to be more technical on this one. I'm not going for the technical part. You can explore by your own. So the example of this one, the smart agriculture using IoT and cloud. The farmers deploy soil sensors connected via LoRaWAN and data sent to Google Cloud IoT and dashboard analytics, and we can do anything after that. Either we want to do the automation, such as the irrigation and so on. So workflow, soil moisture, threshold, trigger irrigation. If the threshold is passed, they will trigger the irrigation. And data stored in BigQuery analyzed with AI for yield prediction. And outcome, 25% of water savings, 15% of productivity increase. So this is the benefit of using the IoT and cloud. And some example we can see together on this one.
The smart agriculture system monitors parameters like soil moisture, salinity, NPK value, and pH of the soil, as well as the levels of carbon dioxide, oxygen, and light intensity above the soil. These parameters are monitored by the sensors equipped in an IoT device, which is known as a sensor node. The sensors are positioned at various depths to collect data from multiple soil layers. Farmers can customize the parameters to their unique soil types and crop needs by setting specific thresholds for each parameters. The sensor nodes form a powerful mesh network where data flows from sensor nodes to branch manager and from branch managers to the central gateway. The location of the devices that make up the mesh network can be seen on the dashboard. The real-time information on each sensor node can be visualized to monitor alerts and detect potential problems before they affect the crop. Smart agriculture system doesn't just inform, it empowers. The system provides real-time alerts and actionable recommendations assisting farmers with the optimal crop management strategies. Farmers can make informed decisions to optimize crop yield with data analytics and historical trends. Agriculture is changing, and thanks to smart agriculture, farmers get the tools they need to make every harvest their best.
Okay, guys. So this one is basically some of the information regarding on the utilization of the smart agriculture by using the IoT and cloud to manage effectiveness of the savings and also to increase the productivity. So again, the what we call the IoT and cloud is basically whenever you use it properly, we can manipulate things, we can increase the effect. Okay, I think that the line is going to be disturbed a bit. All right. Regular patterns and send alert, and then remote patient monitoring market expected to reach by 175 billion USD on the 2030. So this is a big market as well. And outcomes reduce hospital readmission by implementation of this one.
A glass of Dutch lady milk brings 7 times more vitamin D than your usual breakfast to help.
In the decades ahead, healthcare will undergo dramatic transformations. Medicine will become more precise. Value will shape care delivery. Patients will become empowered consumers. And digitalization will transform every facet of healthcare. Patients will have a digital twin, a customized computational model of themselves, enabling Dr. Clive to anticipate illness, guide therapy options, and predict outcomes of procedures. Expanding precision medicine will enable radiologists to make highly specific diagnoses for Stephen without unwarranted variations. AI-powered decision models, fed by vast population health data, will improve diagnostic accuracy. Healthcare will become anticipatory, organized around Paula's medical conditions, and available around the clock, transforming care delivery. Multidisciplinary, highly productive teams structured around patients and their needs will collaboratively deliver the full cycle of care. All interactions with John will become convenient, personalized, and compassionate, improving patient experience. Supported by real-time monitoring and guidance, John will become more empowered and have physical and virtual access to care when and where he needs it. At Siemens Healthineers, we are enabling healthcare providers to increase value, shaping the future of healthcare.
Okay, guys. So there is some videos for us to have. The example of how the implementation of the smart healthcare by using the IoT and plus the cloud is going to be in the future. Currently, this is happening. Right. So this one is basically giving a lot of benefits to the ecosystem of healthcare, by which it increased the efficiency and effectiveness of the hospitality services and so on. All right. So smart city, as we will look further, such as for the Jakarta smart city, previously we discussed about this one. The impact of this one, 20% reduction in flood response time because of the effectiveness of the ecosystem, and real-time open data portal for transparency. So the architecture in this one, IoT sensors such as a 4G, 5G, cloud platform, AI dashboard, and public API. So this one is the smart city example. And then the most important thing in this one is the security and privacy in IoT cloud system. The threats, basically data interception during transmission. As we know that a lot of scammers nowadays, you know, divert us into the different platforms, you know, the phishing, the scam, and so on. Unauthorized access to the cloud database and weak IoT authentication, compromised firmware updates, and so on. So the security solution for this one usually taken by the providers is end-to-end encryption, token-based authentication, blockchain-based entertainment, regular OTA updates. So the blockchain is basically game-changing here because of all the ledgers of the what we call transition is basically being stored in the blockchain, which is being logged in the blockchain. So 42% of IoT projects face data security issues. Still, what we call a big number of the data security issues because of the emerging trends in the security is still in the progress. And then the edge and fog computing, this is the new things, the challenge, high latency when billions of IoT devices send data to distant clouds. So solution is basically to use the edge of fog computing as a first, what we call processing, to process the data near the source before uploading to the to the cloud. So for example, smart cameras analyze video locally, only send key metadata, reduces latency by up to 90% and bandwidth cost by 70%. So this one is the new things. So architecture of this one is basically we have the IoT, the sensors, we have the edge node, we have the cloud, we have the application layer. So where is the edge of fog computing place? It's basically after the IoT sensors getting the data, they have the pre-processing before they send to the cloud, and then the application layer to the consumer. So challenges in IoT cloud integration, number one is the connectivity issue, because of some places in this world still have the unstable rural networks, but we have the space uplinks and so on. And then interoperability, many devices standards, Zigbee, LoRa, Wi-Fi, and so on. Security risks, unsecure endpoints and latency delays in real-time processing, and data overload, managing zettabytes of sensor data. So this is basically the challenges. So emerging solution on this one, AI-driven anomaly detection, unified IoT protocols, and data compression frameworks, all right? So the future trends of this one, we have the cloud-driven IoT, by which we have the AIoT, artificial intelligence of things, the new one. AI adds prediction and automation to the IoT. Serverless IoT architecture, such as the AWS Lambda, Azure function. And we have the blockchain integration, immutable IoT data logs that logs every single things without having to, we cannot remove this one, we cannot delete this one. And digital twins, such as in the medical lines, virtual models of real world systems, and sustainable IoT, by which the energy efficient networks, green data centers, and so on. So AIoT market projected to reach 280 billions by 2032, by which the integration is happening right now during our time, all right? So the key takeaways of this one, IoT collects real world data, number one. Cloud processes, analyze, and scales that data. Together, they create intelligent systems, responsive ecosystem across industries. Edge and AI are shaping the next generation of IoT innovation, all right? So by which our IoT give things a voice to show what's happening, and clouds give them intelligence to make sure that we can maneuver properly, all right? So before we move to the final part of this one, the lecture, do you have any question, please? Any question, guys?
Everyone, any question?
Yeah, any question?
You may not asking later. You may asking now. Dr. Kamarul Khairuddin allow you to ask directly.
You can ask.
Yeah. You don't need to wait until the question and answer sessions. You may ask now. No question? All right.
Okay, I think no question, right? So we move to the next part of final part of this one of the lecture today, the challenges and the future trends of the IoT and the cloud computing. So technology is moving faster than our ability to fully understand the impact of this one. So this is Satya Nadella, Microsoft CEO. So the objective here is basically to explore the challenges in today's IoT cloud ecosystem and the emerging trends shaping the next decade. All right. So the fact is the global IoT and cloud ecosystem expected to exceed 2.5 trillion. This is very big amount of value of US dollar, by which the PricewaterhouseCoopers, as explained in 2024, explored in 2024. All right, the skill challenge, data explosion. So this is the problem that we faced. IoT device generate 80 zettabytes of data annually by 2025. This is a big amount of data. To visualize, that's equivalent to every person on earth streaming HD video continuously for a year. Vast amount of data. The issue is basically data overload on networks, need for real-time processing rather than batch analysis. You know that the strategy of the processing things such as the agile methods and so on. So this one is basically different compared to the other things such as for the agile methodologies and others. We have to process it in the real time, meaning whenever the demand comes, we have to settle down the things first. We have to settle down everything, all right? Rising demand for storage and compute capacity. And solution direction, edge computing, as previously we discussed, but fog computing and edge computing. We have the intelligent data filtering, AI pre-processing, and data compression and summarization, rather than giving the full data, raw data, and so on. So that's why edge computing is very important to process the data compression and summarization before sending to the cloud-based ecosystem. So the top concern in terms of the security and privacy, we have the major threats of the data breach, insecure endpoints, weak IoT passwords. So we have to change this narration. AI-driven attacks, smart malware targeting device firmware rather than the cloud system. And cloud misconfiguration, improper storage permission, such as the AWS S3 leaks. Case example on this one, smart home manufacturer exposed 2.6 million user video feeds due to unsecured cloud API. So this one is basically a big things happening in 2021. As for the statistics, 43 of IoT systems experience at least one data leak per year. So this one also is a alarming amount of the data leak, what we call statistics. So mitigation measures, end-to-end encryption. One of the most what we call successful implementer of this kind of the security measures is basically Apple ecosystem, by which they have a very, very what we call tight security measures, very good security measures taken into the ecosystem, into the place. So mitigation measures into this one, end-to-end encryption, multi-factor authentication, blockchain-based data traceability, and zero trust architecture. All right. So interoperability and standards. Thousands of IoT devices, different communication protocols, and poor integration. So this one is happening right now. For example, we have the Amazon, we have the Zigbee, we have the LoRa, we have the Bluetooth versus the Wi-Fi, different platform, and so on. Proprietary vendor cloud such as the AWS IoT not talking directly with Azure IoT, similar to the Apple not talking to the Amazon, and so on. So emerging solution, the Meta Protocol 2023. Universal IoT standard by Apple, Google, Amazon to be implemented. Open Connectivity Foundation, OCF, for interoperability. API standardization, REST, MQTT, and JSON. By 2028, over 70% of IoT devices are expected to support cross-platform protocols. Nowadays, we can see that even from the Xiaomi, although they have the smart home for the Xiaomi, they also have the integration with the Amazon. They have integration with the Google. They have, some of them have integration with the Apple as for the home, smart home application, and so on. So this one is basically emerging happening because of they want to have the standardization to make sure that they can communicate with each other. All right. So latency and network bottlenecks. So the challenge is basically sending all data to distant clouds. Data center increases latency or delay. So for time sensitivity applications such as the car, autonomous car, industrial robots, even milliseconds matter because of, you can see that when we talk about the security, safety, and so on, the car is basically poses into the security matters to the most. All right. And then the solution is basically edge computing, process near the device, fog computing, intermediate layer between edge and cloud, 5G networks, less than 10 millisecond latency, enabling real-time IoT. So the fact is 5G adoption can improve IoT responsiveness by 95% compared to 5G. So this one is basically happening right now. So we have the solution already in place. The cost and sustainability, the problem is IoT and cloud consume a lot of power. Data centers already use 2% of total global electricity. E-waste and carbon emission are rising due to the connected devices. So this one is basically the problem. So the trends toward the sustainability, the green data center, solar, wind power cooling system, and some of the servers by China, by Germany, and so on, they put it underwater server. Like China, they put underwater in the sea, in the seabed area, so they can do the liquid cooling without any problem. And then the circular hardware economy, recyclable IoT devices. So for the case, Google Cloud achieved 100% renewable energy operations since 2022. How they do it? So you can look into the Google Cloud, the method of achieving the renewable energy by the Google Cloud. They're using the solar panels, they're using a lot of other renewable energy implemented altogether. All right. So ethical and regulatory issues, we have the surveillance and privacy personal IoT data, AI bias in decision-making systems, such as different countries, different places, policies, and so on. So we have the concerns in terms of the AI bias, cross-border data laws, such as the GDPR, PDPA, and so on, accountability in autonomous systems, such as the self-driving accidents and others. So emerging framework in the development, EU AI Act 2024 regulates the AI and IoT data usage. We have ISO, we have the Malaysia's PDPA 2023 revision. So also we have the new AI regulation in Malaysia, for example. So I believe that in Malaysia, you have also the similar things happening to make sure that everything is in place and ethically being run. So, all right. So the future trend on this one, as being mentioned previously, artificial intelligence of things, we have the AIoT, IoT plus artificial intelligence, smarter self-learning system, such as the predictive maintenance in factories, smart health diagnostic, autonomous drones, and vehicle intelligent energy grids. All right, so this one also a big amount of the value by market, and it's going to be something that is very big. And the Tesla already implemented this one, combines IoT sensors such as LiDAR cameras plus AI model on the cloud GPU. So this one is basically being implemented, but of course in the place of the wire connectivity without any problem and without any laggings. All right. The future trends number 2 is the serverless and edge fusion. The serverless computing lets developer to deploy IoT function without managing the servers, because of they don't want to face the headache infrastructure and so on. Edge nodes executes pre-processed logic, only sending crucial data to cloud, meaning they have the pre-filtration. An example, AWS Lambda, we have Greengrass, local processing plus cloud coordination. Azure function with IoT Edge for offline AI interfacing. So the benefit of this one, lower latency because of the data sending to the cloud is basically the simplified data, and data that can be what we call they can be understandable by the cloud, and energy efficient and cost optimized. So by 2038, 50% of new IoT workloads will be processed at the edge, not by the cloud itself, but by the edge. So it can reduce the latency furthermore. So the future trend 3, digital twins, as we discussed in the medical lines, digital twins is basically a real-time virtual replica of a physical object system of process. Smart factory twins simulate equipment wear before failure. So urban twins simulate traffic power and flood patterns. So some of the emerging trends now, such as the Airbus, such as the airlines, they also have the digital twin of their aeroplanes and so on, to make sure that they can simulate the equipment wear before the failure things are going to happen. So this is very important approach to make sure that all the consideration of having the maintenance and everything is taken into the very first place before they are going to put into the physical implementation. Used by Siemens, Singapore, Smart Nation, and Airbus to reduce maintenance costs by 30 to 50%. So the technology stack here is basically they have the IoT sensors, they have the cloud analytics and AR, VR visualization to make it as a digital twin. All right. So future trend number 4 is basically quantum cloud and blockchain IoT. This is very important. This is very emerging right now, and this is a new innovation. Uses quantum processors for ultra-fast analytics and encryption, future ready for high security applications such as banking, defense. But of course, for the quantum, they're still looking into the correction because of some erroneous over there still there. By means, if we have the 1 and 0 processors, such as the conventional processors, we know that they are very effective, they are very efficient without any errors. But for the quantums, there's still a room for errors, margin for errors in their calculation. And then the blockchain in IoT secures peer-to-peer IoT transactions, ensure immutable data trail users in supply chain. In the UTM ecosystem, we have the honey traceability by our technology by using the B modular box. We have the technology in UTM uses the blockchain to monitor or to trace the honey productivity in the farming ecosystem. So the fact is, by 2030, 20% of IoT systems will integrate blockchain for security. So this is going to be emerging and going to be there. But the thing is, although we have the blockchain, we have to remember the storage for the blockchain is also plays a very important role because of any single amount of the blockchain we cannot delete, we cannot remove that one. So the storage is going to be bigger and bigger and bigger. So as for the summary, the connected future, we have the journey so far. We evolve from distributed, we have the cloud, we have the edge. IoT gives data, cloud gives intelligence. Please remember that one. Virtualization made it scalable. AI made it smart. So the next wave is basically sustainable, secure, and smart IoT ecosystem. All right. So the future of IoT and cloud is not just about the connecting devices, but it's all about the connecting purpose, people, and planet. All right. So that's all for the lecture. If you have any question before we move to the next part of the activity, any question, guys?
Guys, before we move to another activity, any questions?
Yes.
Do we open the question and answer session now, sir? Or
yeah, definitely. I think we
okay.
can move on there.
All right, participants, you may directly ask your question by raising your hand and unmuting your microphone. Or if you prefer, just drop your question in the chat box and I'll be happy to read it for you. Please, before we move to other activity, a question. Don't be shy, guys.
Yeah.
Better to ask here because we don't have, like, especially for Telkom University students, you're not in Malaysia, you can't ask Dr. Mohd Khairudin directly. This is your place. For Malaysian student, maybe can go to UTM, but Indonesian students, this is only your place, guys.
Yeah.
Come on, any questions? Okay.
Okay. Any questions? If no, I will move to the briefing of the activities.
Okay. Please, Doctor.
Okay, all right. So I think the students, they have a lot of questions. Maybe they need some time to process the things, 2 hours for this IoT and the what we call the cloud computing is basically not enough for them. So this is quite heavy. But we move to the class activity now to look into the understanding of the students. All right.
Okay.
So the post-lecture activity is basically you have to design your own IoT cloud system. Okay. So this one is best for 1 hour, and we have the bonus time here since we finished the lecture earlier. So I hope that you your own small groups, either up to 5 students, actually not just only 3 to 5 students. So this one you can use any platform such as a PowerPoint, Canva, and so on. But the submission format will be in the PDF format. So the submission method, please email the representative of the group please email the PDF to my email. I will share this slide to the organizer as well. So the submission deadline is basically today, 4 or by 12:30 at noon. Okay, I think we can follow Indonesia time. And then the objective of this one is to apply the concepts, learn about IoT and cloud computing by designing a simple, realistic IoT system. It's a very simple one, all right? So by completing this activity, students should demonstrate the understanding of, number one, IoT architecture, data flow, cloud services and deployment model selection, real-world problem solving through digital systems. So this is the objective. The task description, so you have to put yourself into the technology consultant, developing a small IoT cloud solution for a community, industry, or campus setting. So your task is basically, you have to design and describe IoT system that uses cloud computing for data processing, storage, and visualization. Okay, the bonus thing here is basically, it's going to be simpler for everyone. You are allowed to utilize AI, such as ChatGPT or else to assist in this task. Very simple one, all right? So it's going to be very simple, but you have to make it more unique to your preference. The task description deliverables, okay, all right? Number one, you must have the diagram. Show how sensors, networks, clouds, and application interact. Indicate at least 4 components, all right? What kind of components? You can ask in the AI directly without any problem. IoT device or sensor, gateway or network, cloud layers, application layer. Again, the objective of this one is basically to make sure that you can grasp the understanding of the IoT and cloud computing by at the end of the lecture, at the end of the activities, all right? And then you have to give the brief explanation, maximum just only 1 page. You don't have to do a lot of pages. Include what problem your system solve, type of IoT data collection, which cloud services model, either IaaS, PaaS, or SaaS deployment, all right? How the system ensures security and scalability. And innovation element, you have to put this one creative or future-ready enhancements such as AI integration, edge computing, blockchain, or sustainable low-energy device design. All right, so all of this is basically, it's up to you. Either you want to do in the PowerPoint presentation, either you want to do in the Word file or Canva, it's up to you. The output will be in terms of the PDF, no presentation, for 1 hour only. And we have extra time up until 12:30. So 12:30 is the cut-off line for you to submit everything, the PDF, 1 page to my email. All right. So hopefully the direction is clear. If you have any question, you can ask now. I will share the file of PDF to the organizer. Okay, over to you, organizer. Thank you.
So they must be in a group of 3, sir.
It's quite flexible. Either 3 or 5 students, no problem.
Okay,
So
so
the decision is on.
they create a group outside this Zoom meeting.
Yes, definitely.
Okay, students, before you do, any questions about the assignment? Please make sure
Yes,
you
any question?
understand about before you do the assignment. If you already understand about the assignment, please give me the reaction, the thumbs up or something. The thumbs up is okay. Show me your understanding by share the reactions. Thumbs up if you understand the assignment. Okay. All right.
So we have the thumbs up. All right.
Okay,
That's
all
great.
right. Already they understand. Okay, no question, yeah? You
So,
already understand the assignment, yeah, everyone? All right, so we wait until 12:30 or what do you think, sir?
I think we just only give the flexibility for the students to
Mhm.
prepare the assignments.
Mhm.
You know, I will share the slide of the presenter of the
Okay.
lecture by today.
Okay.
And that by having the AI, such as the ChatGPT and so on to help narrates this assignment, is going to be easier for the students to finish up by the time of 12:30. So I think I will let the students do by their own, and then I just wait for the submission
Okay.
email.
All right, so we can like close the class. We can end up the class and then continue. They will continue independently, something like that, sir?
Yeah, definitely. Yeah, definitely.
Okay, okay. So we don't need to like still on the class. We can end up the class and then they will continue the assignment independently, yeah. All right, so
Yeah,
we wait
sure.
until another question first, yeah, sir, before we end up the class. Before you go to the assignment, guys, last call. Any questions?
Any question?
Oh, no questions? You okay, everyone? 60 students. No questions? Oh, all smart, yeah. So the PowerPoint will be shared in the chat box or in the group WhatsApp, sir. So
Okay, I will
will you
share.
share?
I think the size is I think it's better for me to share through your email. Is it possible? I will
Okay.
send to the organizer's email.
Okay, all right.
If I can have your email, I will send
Okay,
now.
I will send my email.
Okay. Okay.
So is it okay if I share it into a WhatsApp group, sir? To the students?
Definitely, definitely,
Okay.
definitely.
Okay, ready, send my email.
Okay, I just in the email. Okay, now I'm sending you.
All right.
In the meantime, if you any students have any question, you can ask me.
Okay, all right. Can the students reach you out through email or through the WhatsApp group? I will send it to you.
Yes, definitely.
Okay.
No problem.
All right. Okay.
Sure. In any platform, no problem.
Okay. All right. Everyone, Dr. Khairudin will send the PowerPoint, the material to me, and then I will send it to our WhatsApp group. Yeah, the material. Okay, right.
Yeah.
Last call. Is there any questions before we end the sessions for today regarding to the material or the assignment? No question?
Okay. I already sent the email.
All right. We end the class now, sir, or we still wait for the questions?
I think that's all from my side. Maybe some pictures we want to take on together.
Yeah, we will take a pictures before we end the sessions. All right.
Okay, sure.
So everyone, please turn on the camera. I'll take a pictures of us before we end the sessions. Okay. Let me take a pictures. Ready? All right. Please give me your best smile, yeah? 1, 2, 3. Okay, another slide. 1, 2, 3. Okay, right. Thank you. And then, yeah, Doctor, before we end the sessions, do you have like a last, like to sum up, to summary our class today? Do you want to give us the summary for today? Sorry.
Okay, thank you so much again, Dr. Anissa, for your coordinating one. So as for my side, I really truly happy to meet all of you, the students of the Telkom University. So hopefully we can have this kind of engagement things to be done in the later settings, because of the IoT and the cloud computing is very important things to be discussed in this era. So hopefully by having this kind of 2 hours time setting, short amount of time, you can gain something out of this one. And hopefully it is going to be beneficial for everyone here, for the students. All right. Please don't hesitate to contact me anytime. So I will share. I think you have my email. So no problem in asking me anything. All right. I'm always happy to come to Indonesia. So it is a very, very beautiful and nice place. Alhamdulillah. Okay, see you on later on.
All right.
Bye.
Yeah, thank you. A big thank you to Dr. Khairudin Ramli. On behalf of community, I'd like to express our deepest gratitude to Dr. Mohd Khairudin Ramli for sharing the knowledge and perspective with us today, integrating IoT and cloud computing into accounting educations. And also a big thank you for you guys for attending our class in the weekend, yeah? And then please don't forget to check the chat box. I'll share you the feedback link. You need to fill it, kindly fill out, and as a part of requirement to receive the certificate, and also the feedback for us for our better session, next session, yeah? Wait, hang on. I will share in the, okay. Please fill out the attendance, and then you will receive your certificate letter. And of course, the journey doesn't stop. Yeah, we are still have last class. Our last meeting is next week on the chapter 6, IT governance, which will be held on 1st November 2025. Until then, thank you once again. Stay safe and see you all in the next sessions. Yeah, goodbye. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Thank you,
wabarakatuh.
Doctor.
Everyone.
Thank you, Doctor.
Thank you, sir.
Thank you to all of you. Bye.
Right. Don't forget to fill out the feedback link, everyone.